In this demo I'm going to show how to install and use the value mapper ActiveX control that we have in SpecView. This can be used for a couple of things. One is thermocouple offsets, for example, where you've got a calibrated thermocouple table to apply a calibrated value to an input thermocouple. And the other one is to map one value in SpecView to a non-linear other value. For example, if you've got a voltage transducer, a pressure transducer that outputs a voltage, typically pressures and vacuums end up with a logarithmic scale, so we're going to take a linear voltage and make up a logarithmic pressure scale. First of all though, we need to register the ActiveX control, and in order to register ActiveX controls in SpecView you need to be running as administrator. So on the SpecView icon, if you right click and choose Run as Administrator, we will then be able to register the ActiveX control. So I'm going to create a new project, new manual project, Value Mapper Demo. I'm running in a small window to make sure that everything isn't too big, so things will appear as windows. Okay. Registering the ActiveX control. On the object menu, ActiveX control, register controls, and this is a list of all the currently registered controls on my computer, and I'm going to register another one, and it's UC value mapper that we want. If you didn't run SpecView as administrator, you'll get a little error message there possibly. So now it's been registered. If we zoom down to the bottom of this list, somewhere down here, UC value mapper, so it has been installed. Okay. Now before I use this, we need a couple of Excel spreadsheets to work with. So I'm just going to start up Excel, and first of all I'm going to make a demo thermocouple offset. So you might send your thermocouple away to a calibration service and get back a result that says at 0 degrees the thermocouple is bang on, at 100 degrees it reads 1 degree too high or too low, or whichever it is, 200 degrees it's -1, and at 500 degrees it's 6 degrees above, let's say. Simple little table. The value mapper ActiveX control interpolates values between them. So for example, at an input value of 150, which is halfway between these two, the offset is going to be halfway between these two, which is going to be 0. At, let's say, 350, it's going to be halfway between those two, and halfway between those two is about +2.5 or so. So that's that. We need to save it as a comma separated value file, not as an Excel spreadsheet. So file, save as, and down the bottom here we need to change this to be CSV comma delimited, and we're going to save the file in a place that we can hopefully remember, which in my case is, well, let's put it in the SV3 folder, and I'm going to call it tcoffset.csv. And Excel says, yeah, we can't have multiple sheets, so okay, and it might have fancy features, yes, that's okay. And then when we close the spreadsheet, we don't want to save it because that would try to save it as an Excel spreadsheet, and we already have the CSV, so that's fine. While I'm here with Excel open, I'm going to create the other one, which is for mapping. And what we're going to do is we're going to pretend that we've got a 0 to 10 volt input, which maps to various sorted pressures registered in bar. So 0 volts is going to be 1 bar, 2 volts might be half a bar, 4 volts might be, well, let's make it easy, 0.1 bar, 0.001, 6 volts might be 0.0001, 8 volts might be, oh, I missed. As you can see, it's getting smaller and smaller. 1, 2, 3, 4, 5, 1. So there's a kind of logarithmic scale of an analog voltage from 0 to 10 volts from the pressure transducer is the difference between 1 bar and a pretty good vacuum. So I'm going to save this one again as a CSV, C:32. I'm going to call it pressure.csv. Make sure to change this to comma separated values. Save. Yes, that's okay. Yes, that's okay. Close Excel. Do you want to save the changes? No. Okay. So, we are now ready to start playing again with SpecView. I'm going to create a few user variables to do this with, because I don't actually have a pressure transducer or a thermocouple of any kind connected. So I'm going to play around with, I'm going to call one input TC, and I'm going to have another one which is input voltage. I'm going to have one that's TC offset, so this would be the offset applied to the input, and I'm going to have TC calibrated. So that's the result of the input plus the offset making the calibrated value. And for the pressure thing, let's just have actual pressure. Okay, I'm going to put these on the screen. So the voltage, the thermocouple and the various offsets, I'm just going to stick down there. Let's just make this one up here, slightly the wrong order. Bit messy, but there we are. And then over here I'm going to put the input voltage and the actual pressure. Okay, now I'm ready for some ActiveX controls. So on the toolbar is the ActiveX control insert thing, and I'm just going to plonk one here. Big wordy warning, have a read at your leisure. To start with, the ActiveX control that we registered is not in this list. This is a subset of the total number of ActiveX controls on the computer, and we want to add our value mapper to this list, so we'll click the See More ActiveX Controls button, and we will find UC value mapper. Okay, so that now appears in the list. That's the one I want. Okay, here's the ActiveX control. It has a little user interface of its own, so you don't really need to put this stuff out on the screen, but whatever. Now, a quick note about selecting ActiveX like this. When you click on it, because it's got its own user interface, it absorbs the mouse clicks from SpecView, so you can't actually select this ActiveX control because it's always taking the mouse. So a neat little trick is to, outside the ActiveX control, drag a rubber band box which goes over the ActiveX control, and now that you can see it's highlighted with the hatching. So we need to specify some values, so let's go to Object, ActiveX Control, Link to Variables, and what we're going to do is the input to this ActiveX control. First one is going to be the map file name, so we need to specify, unfortunately there's no way to browse for this, so you need to have written it down or remembered it from last time. You need to specify the file name of where the values are going to come from, or rather where the offsets are going to come from. So in this particular case it's tcoffset.csv. Then we need to specify the input value. This is going to be the input thermocouple. It goes in there. And these two are outputs. So on the output tab, the mapped value is going to be the offset, and the adjusted value is going to be what I've called calibrated. Okay. While I'm here, I'm going to make the second ActiveX control, which is the one that's going to do the mapping between voltage and pressure. So click on ActiveX control, drag out another one, lots of words, and we want a value mapper. Okay. There it is. Object, ActiveX control, link to variables. So this time the file name is going to be pressure.csv. The input value is going to be the voltage from our pressure transducer, and then on the outputs the actual pressure is going to be the mapped value, I'm not really interested in the adjusted value, which is the input plus the mapped value. I'm only actually interested in the mapped value, so I'm only going to feed one of the outputs. Okay, so those are there. Let's save this. That's demo. And go into runtime. Let's see what we get. That's probably a good idea to have the Excel spreadsheets up again, just to have a look and see what's going on. So here's Excel. So here's the thermocouple offset table, just so that we can see what goes on. So over here in SpecView, if we feed in a value of 100 from the CSV, if the value is 100, we need an adjustment of 1. So there's the offset 1, and here's the calibrated result. So let's play with some other values. Let's type in 200. Just going to take off auto close there. So at 200 we have an offset of -1, and anywhere in between. So if I type in 150, the offset's going to be 0, because it's halfway between the 1 and the -1. And if we type in like 350, which should be somewhere between the others, we get a value of 2.5 to make a calibrated thermocouple reading of 352. So that's basically taking the input, adding the offset to give a calibrated value. So over here on the adjustment, let's get the other spreadsheet up. That was pressure. So this is where we're taking a voltage and making a variety of pressures. What I haven't done is I haven't changed the number of decimal places for this value here, so that when it starts to get really small it doesn't just display 0. So I'm going to go offline, click on that value, ungroup it, and I'm going to do edit dynamic attributes, display format. Instead of being free, I'm actually going to go into, well, to start with I'll put 4 decimal places, but also I'm going to put the value on the screen again, actual pressure there, and I'm going to make the display format scientific notation. So I'm just going to have 3dp scientific notation. Save and run. Okay, so with an input value of 0, as you can see from the spreadsheet, that's 1 bar, and as the pressure goes down and the voltage transducer goes up, you can see that with an input value of 2 volts, the mapped value is 0.1, and as we go up the voltage, the pressure gets smaller as the ActiveX control maps one value to another. As you can see, it's beginning to get really small, and this is where the scientific notation starts to kick in. So 7 volts is 5.5 times 10 to the minus 5, 8 volts, 9 volts, and finally 10 volts, maximum vacuum 1 times 10 to the minus 6. So as you can see, the same ActiveX control can either be used to add a varying offset to an input value to give the result, or it can map one value to a completely non-linear range, like with these pressures. Thanks for watching.